Hi, this is my lab report for Lab 4 bar magnets. The purpose of this lab was to measure the distance-dependent magnetic field of a small bar magnet, and there's like a small preview of the results. The slope was negative 2.676, and the magnetic dipole moment was 3.8837 approximately. The system in the observed model was the bar magnet, and the surrounding was everything else. These are the fundamental physics principles used. The Biot-Savart law, which states that which relates the magnetic field at a point to a tiny current element, and that's the formula. And a magnetic field of a magnetic dipole is a closed circulation of an electric system, and that's the formula for that. And the distance dependence formula, which says that the magnitude of the magnetic field due to a bar magnet reduces as the distance increases, basically, and that's the formula for that. These are the steps for the experiment for the observed model. So you orient the phone to make the magnetometer orthogonal to the Earth's magnetic field, and then you find the location of the magnetometer chip on the phone, and then you measure the distance between the magnetometer and the bar magnet for on and off the axis. This is the data we collected, and the slope over here is negative as because as the distance increases, the magnitude of the magnetic field it decreases. These are the calculations used to find the slope and other constants. This is the data for the off-axis, and this is the code. This is the code I wrote to uh, create a visual image on a glow script to help visualize the experiment. The similarities and differences between the observed and computational models. In the observed results, that was the off-axis magnetic field, and the magnitude was 5.6048 to the times 10 to the negative 5 approximately, and in the computation model it was 3.49 times 10 raised to the negative 5. And the assumptions and the potential errors. So we had two assumptions, which where the bar magnet acts as a magnetic dipole and the magnetic field falls off as the distance increases. And the two errors, which could have been the two possible errors, were the other objects nearby that were electronic or magnetic that may have skewed the data on the magnetometer, and the exact location of the magnetometer was not found precisely. Yeah, some of the observed statements were that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x hat direction. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. The discussion. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some immediate angle with respect to Earth's magnetic field? How would your results have changed? The Earth's magnetic field would interfere with the bar magnet's magnetic field, which would mess up the results. And what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The magnetic field's magnitude would then double, but the direction of the magnetic field would stay the same. And basically, in this experiment, we learned about power magnets and how to calculate the magnetic dipole moment. Thank you.